Hey everyone, I'm Joshua Deemer and welcome back to Lesson 9 of our Java Programming Tutorial series. Let's jump right into the lesson. Before we jump into methods, we need to talk about modifiers. There's 3 specific ones I want to go over, 1 in detail and 2 very briefly. The final keyword, which we'll go more into detail about, and the public and static modifiers. The public modifier is an access modifier. It means that these methods and variables are accessible from other classes and programs. The static modifier is a non-access modifier. This is used on variables and methods in order to change a certain aspect of it. We'll cover that more in classes. The final keyword is a little bit different. Here we have int a equals 5, final int b equals 10, and you see there's no errors there. And then we print out the addition of the two. If we run this, it runs like normal, 5 plus 10. Okay, so what's so special about this final keyword? Well, let's go ahead and see a plus equals 5. If we run this, this should make it 5 plus 5, which is 10, and so we should have 10 plus 10, which is 20. And you'll see that we get 20. Well, let's go ahead and try to do b plus equals 5. You'll see that there is an error, and this is because of the final keyword. What that means is this is a constant number and a constant variable with the number 10, and it cannot be changed. One very specific use for the final keyword is with magic numbers. So let's go ahead and do this. For example, let's say we have int miles is equal to 2. Then we have int kilometers is equal to miles, and I believe the conversion for it is multiplied by 1.6. Firstly, there is an error, but let's continue. System.out.println miles plus miles. System.out.println kilometers plus kilometers. Okay, so we have this error first. This is because this number is a double, and we're trying to convert that into an integer. That doesn't work that way. So what we can do is we can change miles to double and kilometers to double. And you can add the 0.0 on the end if you want, but let's go ahead and run this. And it says there's 2 miles, and it's converted to 3.2 kilometers. This is known as a magic number. We're just plugging in a number, not really explaining what it is. The final keyword, so if we say final double mile to kilometer conversion is equal to 1.6. And we paste that into here. This suddenly makes a lot more sense in our code. We are assigning a final, unchangeable variable to 1.6, and we're naming it something that makes sense to us. So we then take the double miles equals 2, and the double kilometers equals miles times the mile to kilometer conversion. This makes a lot more sense in our human minds to, okay, we're multiplying it by a conversion number rather than just straight up saying 1.6. This also gives us the same result. Methods can be a bit tricky, so let's break them apart a little bit. First of all, they're used to lessen repetition, and they're understood as functions. The syntax for a method is the modifier, the return type, the method name, Then in parentheses, you have your parameters. Then you have your curly braces, and then your function code inside those curly braces. Let's break each of these apart bit by bit. Let's go ahead and put together our first method piece by piece. So this main method here is, in its name, a method. So we need to go outside of this. So we're going to enter our modifiers. This can be public, this can be private, this can be static, this can be public static. We're going to stick with public static for this lesson, but over time we're going to learn more about what those keywords mean. So those are our modifiers for our method. Then we have the return type, which can be void, it can be int, it can be double. For now, we'll do void, just so we can get used to methods. Then we have our method name, and I'll just call it test. Then we have our parentheses and parameters. I don't really care for parameters right now, and so I'm going to leave it blank. We add our curly braces, and now we have our method. So the usage for methods, like I said before, is to reduce repetition. Let's say in our main method, we have system.out.println test. And I copy this 7 times. Well, this is very redundant. If I run this, then yes, you'll see there are 7 tests. Okay, so how can I reduce this amount of quote-unquote labor? Well, we can take one of these and put it inside of our test method. Then all I need to do inside of here is to call our method test. And if I want to do it 7 times, I do it 7 times. Running this will have the same result, because what we're doing is the code starts here, then it goes down to here. And so this test calls this method and runs everything inside of it. If you had test 1, 2, and 3, then you'll see it'll say test 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 over and over 7 times. Because this test calls this function and it runs everything in it. Then this test calls the function and runs everything in it. And this test calls this function and runs everything in it. And you can see the pattern here. This is how functions work. You can have more complicated things inside of your function, like for int I equals 0, I is less than 10, I plus plus. And you can say system.out.println test number, and then you add I. If I run this now, we'll have 7 tests of 10 prints. If I run this, you'll see that this is true. It's pretty big, however, it is working as intended. You can also always do this for int I equals 0, I is less than 7, which means it'll run 7 times, and you put your test in there rather than running it here 10 times. You can also simply remove it and do this if you want. Of course, you would need to change your I variable because that variable already exists. But there's plenty of different ways that you can use functions in your code. So we have our method here. How can we use this to be a little more flexible? Like, for example, you can see in this main method string array args. Like, how does that work? What is that? Those are what we call parameters. So let's say, for example, I have system.out.println, and we have hello. Now, this is all fine. If I run this now, it'll say hello. Okay, this is fine. But what if I want to flexibly change this print line every time I run a new test? Like, let's say I want this test to say hello, this test to say world, and this test to say test. Well, right now, all they're going to do is say hello 3 times. That's what parameters are for. Inside of here, you can put variables to pass through. So for example, if I say string data, so this is the name, and this is the data type, okay? And then I put data in here. So now I'm taking this parameter and plugging it into the print line. You will see that these 3 tests now have errors. If I hover over them, it says the method tests string and the type program is not applicable for the arguments blank. That's not a 0, those are parentheses. So it's saying that our arguments inside of these parentheses aren't matching the parameters here. What we have to do is we need to match our arguments. So if I add quotes, you'll suddenly see that the test error goes away. That's because I'm now passing a string in for my parameter. If I say here hello, and I say here world, and I say here test, and run it, you'll see that it now prints it flexibly according to the data that we pass in to our function. And you'll notice it very similarly here. If I say system.out.println, this print line is actually a function that Java provides for us. If I reveal this, you can see a bunch of different arguments that we can pass in. So you've been secretly using methods all this time. If we were to say string hello equals hello, and we type hello dot, these are all methods inside of the string class or the string data type, however you want to understand it. These are all provided to you by Java. Let's go ahead and see what happens if I type in 1 here. There's now an error again. Even though we have the argument filled in, if we hover over test, it's not going to let me hover over. Let's go over here. It says the method test string is not applicable for the argument's integer. Well, that's because a 1 is an integer, not a string. If we change this to be an integer, this would work now, but these do not. Let's go ahead and do one more example. Let's go ahead and call this addition. And now we say int left, int right. So the left side of the equation and the right side of the equation. Now what we can do is we can say int result is equal to left plus right and pass result into our print line. I mean, we could obviously just do left plus right in here, but I want to break it down a little more. You'll see there are errors in our tests. That's because we require 2 arguments now. Okay, well, first of all, it's not called test anymore. It's called addition. If I run addition like this, you'll see its color changes, which means it's spelled correctly. But if you notice, it says the method addition in the type program is not applicable for the arguments blank, and it's requiring 2 integers. If we go ahead and say 5, this is still invalid because we need 2 integers, because that's what we told the addition method to have as parameters. So if we put comma 3, now there's no more errors. If we run this, you'll see it prints out 8 because 5 is passed into left, 3 is passed into right because of the order that we put this in. They're added together and the result is printed. We can definitely see this if we say system.out.println left plus right plus right. Now if we run this, you can see the left is 5 and the right is 3, just as we passed into here. If I say addition to 7 and run this, the next result's going to be 9. And the left is going to be 2, the right is going to be 7. Hopefully me breaking this down like this helps you understand methods better. There's a couple more things to address with methods, so let's break them down a little bit more. We have string hello equals hello, and then I say string lowercase equals hello.to lowercase. Okay, so how do we make it so that we return something with our method so that we can store it in a variable? And so if I run this, you'll see that it's the lowercase hello, just like we've been practicing earlier in our earlier lessons. But how do I say something like int result equals addition 5 and 3? This is going to throw an error because it cannot convert from void to int. Well, if you were paying attention, you might have figured this out by now. Void is right here. This means that there is no return type. You can't return anything. This is just kind of like a function that runs and accomplishes some kind of goal. But if we input some kind of return type here, such as an integer, or a double, or a float, or a string, then we have some kind of return type. If I return this to void, you'll see there's no errors. But once I type in a return type, there is an error. If I hover over it, it says this method must return a result of type int. We're not returning anything. And that's going to cause some issues. But now, if we look over here, I can say int result is equal to addition 5 and 3. There's no more errors here because the return type is int. If I change this to double, there is now an error here because it's not going to be able to convert a double to an integer. If I change this to a string, the same thing will happen. You can't convert a string to an integer. Okay, so your return type must match the variable that you're storing it in. Of course, even if you don't want to store it, you can still have it like this and run like a void method. So let's say int result equals addition. Now let's address this error here. We need to return something. So we use our return keyword and we can say 0. This return type matches our integer. If I said 0.0, this would throw an error because it's not matching our return type. If I said double, this would not return an error anymore, but of course up here there would be that error because we would need double here. But let's go ahead and change this back to int. And okay, so if we were to say system.out.println result here and run it, it will say 0 because we're returning 0 and storing it into result. Well, how do we use this 5 and 3 in order to print it out? It's just as we had it before. We just say return left plus right. Since they're both integers, there's no problem here, and we can return an integer there. If we run this, it'll say 8. So let's go through it step by step. First, we start up here. Then we run addition and pass 5 to left and 3 to right. Then we add left and right and return it as the value that addition is. Then we store it in result and we print out result, which is 8. We have one more thing to discuss in methods. If I run this, you will see main method runs, but test method does not. Why is it that main method is always the one that runs? Well, in every single program, there needs to be some kind of entry point. You need to be able to tell the computer, oh, go ahead and enter here. Go ahead and start your program here. That is what this main method is. And it's that case with quite a few different languages, including C#. C++ is a little bit different, but it still has an entry point. Programs always have an entry point, which, again, is this main method. you need to call other methods from your main method in order for them to run. So once we run test here, it'll now say test method. If we run it above, it'll say test method above main method, because main method is now underneath. These string array args are arguments that you pass in if you run this from your console. Now that we have a little bit of understanding of methods, let's go ahead and practice them. So what I want you guys to do is create 5 methods, 4 of which return different types, such as like int, double, string, etc., and 1 which is a void. Only one of these 5 methods can be without parameters, but if you wanted to have all of your methods have parameters, that's fine. One of these methods, though, has to contain 2 parameters, and another method has to contain 3 parameters. The rest of your methods can be 4, 10, 20 parameters. They can be 0 parameters, 1 parameters, whatever. Or 1 parameter, whatever. But 2 of your methods have to match these. Then we have to run every method at least once. Twice if you're feeling daring. But if you want to do this on your own, feel free to pause the video. Otherwise, we're getting started right now. So, I'm going to start with my void one, and I'm going to make it a little more complicated than what you guys have seen and use data types you haven't seen yet. So I'm going to say public static, start with our modifiers, then have the return type be void, and I'm going to say debug. And in parentheses, I'm going to add calendar, date, string, text, and boolean is error. You'll notice calendar has an error, so I'm going to import it. Okay, so inside of here, I'm going to say int hour equals date.get calendar.hour. I'm going to say int minute equals date.get calendar.minute. Then I'm going to say int second equals date.get calendar.second. Okay. Now, let's go ahead and say if is error, then system.error.println. Then we'll say hour plus colon plus minute plus colon plus second plus an arrow space text. Otherwise, in fact, what I can do is I can say up here, final string message is equal to, and I can take these and paste them here. Actually, I'll need to move these up and have the message be underneath. So the error will print out message, and otherwise it'll be out.println message. Okay, let's go ahead and say debug calendar.getInstance, and then we'll say debug point reached, I guess. And it's not going to be an error. So we're passing in the calendar, we're passing in a string text, and then we're passing in our boolean is error. And if I open up this, you can see here calendar, string, boolean. So it matches our parameters. If we didn't match our parameters, it would tell us, it would say, this is the actual one, and this is what you provided. So let's change this back to false. Run this, see if it works. So it says 138.8, so that means it's 138, and it's the 8th second. And then it says debug point reach. Okay, if I change this to true, it would print it in red because that's the error text. But let's keep it false for now. Okay, that's our first method. Now what you can do with your methods, in Eclipse at least, it should be possible in other IDEs and places, but there's this minus button that will close the method. It's still there, it's just collapsed. Let's work on the second method. So I'm gonna say public static double. Then we're going to say division. And here I'm going to have double left, double right. And I'm going to return left divided by right. Cool. Next one, let's say public static double addition. We'll just continue down that trend. Say int left, double right. Then we've got return left plus right. Since we're adding a double to an integer, the return type will be a double. If I were to say int here, it would throw an error. Then let's go ahead and say public static float subtraction. That's right, I have them as different types. So let's make these integers and this an integer so that it's a different data type. Subtraction, then we'll go int first, int second, int third, int fourth. And we'll return first, minus second, minus third, minus fourth. Then we'll have one more, public static boolean has permission. And we'll say int permissions, int user. We'll actually just say int user permissions. And I showed you guys this before actually, but we'll see if you guys recall it. Public int, or final int permissions is equal to 0b00100010. Okay, so those are the permissions. Then actually we need to pass in the user permission and int specific permission. We'll just do 0b1111. We'll just do that. Then, oops, I don't know why I added a space there. Then we need to check if, so we need to say return if the user permissions actually I don't think we need this. We just say user permissions and specific permission is equal to the specific permission. Yeah, we don't even need this final. Okay, and then we need to surround these with parentheses. There we go. I'll go over that in a little bit. So let's go ahead and say system.out.println division, and then the left will be 6, the right will be 3. System.out.println, we'll say addition of 10,000 plus 550, or 5,555. And we'll say system.out.println subtraction, which will be 1 minus 1, or it's not 1 minus 1, 1, 1, 1, 1. 4 numbers because we made 4 parameters. Then let's go ahead and say system.out.println has permission, and we'll say the user's permissions are 1101, And the specific permission we're looking for is that one. Let's go ahead and run it. It says our debug point is reached. We're getting 2.0 as the result of our division. We're getting 15,555 from the result of our addition. We're getting -2 for the result of our subtraction. In fact, let's change this a little bit. We'll change this to float for all 4 of them, because we are returning a float after all. So if we say 1.0 in here, there's going to be an error. That's why we need to add our f. 1.0f, 0f, 0.0f. We can do something like 0.5 if we want, but we'll just leave it like that for now. And remember, this 0b means the prefix is going to be of binary, and you'll see that this is actually true, because this one and this one are both 1. So what I'm doing is I'm checking if they both have this 1, and then I'm seeing if it's equal to the original of this. If this was 0, then it would be 0, because this and this are not both 1. Then it would be 0, and so this would not equal the specific permission anymore. And so it would return false. So if I save and run this, it returns false now. So you can do permissions in this way, like I described before. If I put a 1 here instead and run it, it'll say false. I can also do multiple permissions, and so I can say the 1 has to be here and here, here and here. So if I run this, this will say false, but if I say 1 here and here instead, it'll say true. From here on out, the topics will become more centered around object-oriented programming and will be more complicated and abstract. However, that's the end of this episode. Next episode, we will be covering classes in Java. Thanks for watching. Feel free to comment what your thoughts are on the series so far down below. Don't forget to like, subscribe, and ring the bell so you don't miss a video. Bye!